Have you ever wondered how computers work on 0 and 1? Have you had a hard time explaining or understanding the yes and no binary logic? How computers work? And what's common between apples, traffic lights, operation theater, and yes and no, or never grasped what binary is? Then this is the only video you will ever need to watch. We all use the numbers 0 to 9 and their combinations in our daily lives. These are decimal, or base 10 numbers, or Arabic numerals. In this video, we will use English and recreate binary mathematics out of it. This is a tune. This is its frame of reference to see or experience stuff. There are two main questions it needs to answer. What is the stuff? And how many, or how much, of the concerned stuff is there? So what is in the frame? The answer is nothing. And how much, or how many of nothing is there? This will lead to answers, like, it's an empty frame. None. Nothing. Or transitioning from English to maths with the word 0, although the other answers are correct. But 0 stands out as it is designated as an exact description of the question. How many or how much? It is represented by the symbol 0 and is part of a group called numbers. Math itself is part of a bigger group that we all know as science. Numbers become necessary as soon as precision matters, and math eliminates ambiguity. Else, if we put apples in the frame, it can be a single, a couple, some, or many apples. Single, singular, alone, and one apple are precise answers and represented by the symbol 1. Couple, pair of apples, and 2 apples are also precise answers and are represented by the symbol 2. While some, more, many apples are ambiguous answers as they lack precision. Introducing apples to existing apples is called adding or addition of apples. This comes from Latin word adire, where add means to, and dare means put, so addar means to put something or to put another number. On the topic of addition, please subscribe and add this channel to your list of subscriptions. Since each apple is single, or one apple, in math the addition operation is basically adding 1 to the existing total count of ones. But with only 2 numbers, how do we count or add or do any math? Well, we ask better question and use logic to come to specific yes and no answers. How many numbers are 0 and 1? The answer is 2, or a couple, or a pair. So we need a system where we can use this to our advantage. That is precisely what the binary system does. In fact, the word for 1 in Latin is mono, and for 2 is bi. It would basically count non-pair, or not equal to 2, or single. Then it will count pairs, which is the number 2, and pair of pairs, which is 2 plus 2, or 4, and this goes on. Binary first answers the question, how many non-pair, or singles are there? The answer can only be 0, or none, and 1. So here is no or 0 apple, and here is 1 apple, or as simple as apple no, or apple yes. This becomes our first group, and shows the absence of 2, or a pair. The next question is there a pair, or 2 apples? Since there's 1 apple, the answer remains unchanged. Let's add another apple, and the answer changes. The first answer becomes 0, as we do not have a single apple anymore, and the second answer becomes 1. This basically means 2 in decimal. Is 1 0 in this binary approach? The next question is there a pair of pair, or 4 apples? The answer is 0. Let's add another apple. This time around our answer is still 0, but there is a single apple and a pair of apples. Hence, the answer changes to 0 1 1, which is 3 in binary. Let's add another apple, and now our answer is 1, for we do have a pair of apples or 4 apples, but the other questions are now 0 and 0, thus giving 1 0 0 as 4 in binary. How do we generalize this so it can be used to scale up? Let's use some logic and more questions and operations from math. Multiplication is basically adding 1 for a given count of ones. So 2 is basically adding 1 2 times, written as 1 multiplied by 2, which is 1 plus 1, which is equal to 2. So, multiplication is another form of addition. But since we are using binary, we need to use some operation that uses 2 and makes the answer to be 0 or 1. A yes or no. Now 0 is none, nothing, and shows absence. Adding nothing to nothing will still result in nothing. Having layers of nothing or multiplying nothing would also mean nothing. Hence adding or multiplying 0 give the answer 0. This is the same as you take no apple and put or add no apples would result in no apples in the frame. And taking no apples and adding no apples and repeating this as any number of times will still result in no apples. 0 plus 0 is always 0. And 0 multiplied by 0 is also always 0. 1 when added to itself continuously gives all natural numbers, which means 1 multiplied by any number would be the number itself. Example: 1 multiplied by 10 is the same as 1 added to itself 10 times, giving total 10 as the answer. This is same as adding 1 apple to nothing, followed by adding another apple. Gives us 2 apples. Repeating the addition of 1 apple to nothing and doing it 10 times gives 10 apples. However, an instruction as add 1 apple and add no more apples from there on would always give 1 apple. It does not matter if you read and follow the instruction any number of times. You will always have 1 apple. Hence, 0 plus 1 multiplied by 1 multiplied by 1. Any number of times will always be 1. It's the same as operation of 1 plus 0. Repeated any number of times will always be 1. Multiplying a number with itself is represented as the number and a smaller number on top right of the number, showing the count of times the number has been multiplied by itself. So 1 times 1 times 1 is equal to number 1 multiplied by itself 3 times. That means you added 0 plus 1 and do it 3 times. And every time the answer was the same one. This is written as 1 raised to the power of 3, also called 1 cubed. 1 times 1 is 0 plus 1, multiplied by itself 2 times, written as 1 raised to power of 2, and is also called 1 squared. However, what if we never multiply 1 by itself? That is, we add 0 plus 1. And this was done 0 times. This is written as 1 raised to 0. Well, this is the same as an instruction that states, add 1 apple, and add no more apples, and never repeat it. This would actually freeze the count of apple at 1 apple, 2, 3, 4, or any natural number. Raised to 0 is basically an instruction that says, take any number of apples, add 1 apple, do not add any more apples, and never repeat the process, thus leading to only 1 apple every time. So, this means for our 2 raised to 0 the answer is always 1. This is groundbreaking, as now we can replace our first question by the notation 2 raised to 0, and check if the answer is 1 or 0. A yes or no. Exactly what we wanted. 2 raised to 1 would mean we add an apple, then we add another apple, and we do this only once, which will give us again a yes and a no checkbox for the question. Is it 2 or not? 2 raised to 2 would mean we add an apple, then add another apple, and do this twice, giving us 4 apples. And as you can see the trend, this goes on for 8, 16, 32 and forever. This is represented as all powers of 2 raised to n. This also replaces our question. Is there a pair of pear? Or are there 4 apples? Again, a yes or no solution. So, what is the significance of this? This creates what is called the Boolean logic, a system that allows us to get answers as yes and no, or true and false, or on and off. On the topic of on and off, information can be delivered easily that if it is all about answering a simple yes or no. Is the operation theater light on? No, the OT is empty. But if yes, some surgery is going on, and the OT is occupied. Is the traffic light green? If no, do not drive. And if yes, hit the gas. Is the door locked? No, someone is at home. Or maybe not. But if yes, no one is at home but the house is secured, unless the lock is easy to crack open. Life is full of such events which can be simplified to a simple yes or no logic. Coming back to lights, if we could connect enough of them as a grid, and have on and off switch for every single one, we can display messages as text, and numbers, and pictures, just as people flash their car light or honk to signal each other. Shrink the lights and switches enough. You get your phone or computer or TV display. The switches and connections are printed using light on thin sheets or wafers of silicon, and a high voltage turns them to on or a Boolean 1 state, and a low voltage change this to off, or a Boolean 0 state. This creates Boolean logic operations like AND. This outputs 1 only if both inputs are 1. This is if you were born in your country and still live there. You are a citizen of your country. Or outputs point 1 if at least one input is 1. This is a statement like, if the water looks dirty or smells funny, it is impure and should not be consumed. NOT flips the input. 0 becomes 1 and 1 becomes 0. This is an operation that will change this as a bird to this is not a bird, or the door is closed to the door is open. NAND, also called NOT AND, the opposite of AND. Here output is 0, only if both inputs are 1. This is like a statement. Open the umbrella, only if it is raining, and you are outside, else keep it closed and dry. This is among the most versatile logic out there. There are a lot of other logics like NOR, XOR, and XOR, etc. This is what powers all the logics that work to give us internet, our devices, artificial intelligence, banking, crypto, stock market, Instagram and YouTube. And this leads to your Boolean choice of liking this video, commenting any questions, or sharing words of wisdom, any appreciation, or constructive criticism. You can also support us on Patreon, link is in the description. We will start our videos on English grammar as soon as we hit 5,000 subscribers. For now, we would stick to uploading 80 to 99 videos daily for our ambitious English dictionary project. Also check out our finished projects for Hindi readers on over 2,800 English words with Hindi meaning and another 2,900 plus English words phonetically mapped to Hindi so you can pronounce the English words approximately correctly. As always, wish you a nice day and thank you for watching.